So far in our discussions, we talked about making your own data structures by defining structs. So in a struct, you would define your own fields. Like, for example, you would define a line in terms of the start and end points, and you would define a point in terms of the x and y coordinates. But there is a different way of using data structures without actually defining some super complicated special type, and this is by the use of tuples. So let me give you a very simple example of how this is done. I'm going to make a tuples function here for our test purposes. So let's make this tuples. There we go. Okay, so let's suppose that I have two numbers, x and y, and I want to get both their sum and their product as a single result. So let's see how we can get that. So let's suppose that I have x equals 3, and let's suppose that y is equal to 4, and I want let SP equals, and I want to calculate both the sum and the product at the same time. So I want to feed x and y, and I want to get both x plus y and x times y as a result. One of the ways that you can actually do this is by using a tuple. Now, a tuple is simply several values taken together, but they're not taken together because you have a definition of a struct already. You just take them together, put them in round brackets, and that's it. So let's suppose that this function, and I know we haven't talked about functions yet, but let's suppose that I define the function in the following way. So my sum and product function is going to take two values of type i32, for example, so the x and the y, and what I'm going to return is a tuple. And now a tuple is simply a collection of values of different types. So in this case, I want to return the sum and the product. Both of them are 32-bit ints, so I can define i32, i32. So when I have something like this, when I have round brackets and then values with a comma separated, they don't make up an array or something like that. Instead, they make a tuple. So essentially, from this sum and product, what I can do is I can return x plus y and x times y in round brackets, and this gives me a tuple. So a tuple is essentially a collection of several values which you don't make a struct for, you simply return them using round brackets. So it's almost as if you were returning an array, except that the types can also be different, because with an array all the types have to be the same, like i32, whereas with a tuple you can return mismatching types. You can return an int and a boolean, for example. So here I get my SP, which is the sum and the product, and I can actually output them. First of all, let's actually print line SP itself. Let's see what it actually is. So SP equals, and then we'll use the debug output as before to actually output what we get. And let's run this and see what we get. So we get something which is a tuple with the values 7 and 12, because 3 plus 4 is 7, 3 times 4 is obviously 12. And then, of course, we can be explicit about it by actually getting the values of the tuple. So SP now has two values. It has a first value, which is equal to the sum, and it has a second value, which is equal to the product. So let's try printing those. And I'm going to use the print line. So essentially what we want to do is we want to output the values of x and y and write something x plus y equals so-and-so, comma, x times y equals so-and-so. So I'm going to use numbers here to indicate the position of the argument. So x is going to be at position 0 plus something at position 1 equals the sum, and then comma, once again, x at position 0 times y at position 1 equals, and then 3 would be the product. So how do we, well, obviously the 0 and the 1 correspond to x and y, so these are easy. We just put in an x and a y here. However, how do we get the first and second value of the sum and product? Now, if we want the sum, we just say SP dot 0. That's how you get the first element, the element at position 0. And similarly, if you want the product, you say SP dot 1. So let's try running this. Let's see what we get in this result. So 3 plus 4 equals 7. 3 times 4 equals 12. That's exactly what we wanted to get in the first place. However, it might seem a bit inconvenient that we would have to do this dot 0, dot 1 all over the place. Why not just get the resultant sum and product into variables like A and B, for example? And you can do that, and this is called destructuring. So destructuring is taking an existing structure and disassembling it into separate variables. So what I can do is I can say let a comma b equals sp. What does this mean? It means that essentially I am looking at sp as a tuple of two elements. And you know that those elements are the sum and the product. And I'm saying, can we please assign the first element to the value a and the second element to the value b? So effectively, I'm destructuring the tuple and assigning its constituent elements, assuming that the structure of sp matches the structure that I'm defining here. So I'm saying, well, can we please have the variable a initialized to the sp.0, and can we please have the variable b initialized to sp.1? And this makes it a bit easier to work with, because then I can just print out a and b. So I can say a is equal to this, b is equal to this. And here, instead of doing sp.0, I can just write a and b, which is very convenient. So as I run this, you'll see that I get a equals 7, b equals 12. So very convenient construct. Now, of course, you can also have tuples of tuples. Like, for example, if I make another sum and product, so let's make sp2 using this function that we made, sum and product of 4 and 7, for example. So I now have two of these values, and I can put them into a combined tuple. So I can say let combined equals round bracket sp comma sp2. So essentially I made a tuple of two elements, sp and sp2, but each of these is itself a tuple. So it's a tuple of tuples. And then we can actually try printing out the debug output, comma question mark, like so. Let's put the combined output here. Let's see what this gives us. So essentially we have a tuple of two tuples containing 7, 12, 11, and 28 respectively. And if I want to get a particular value, then I can try doing it using this notation. Unfortunately, as you'll see in just a moment, it's not quite so convenient. So let's suppose I want to print out the last element of this whole thing. So the last element would be 7 times 4, which is 28, and I want to print it. Unfortunately, I cannot write something like combine.1.1. If I try to compile this, you will see that, there is a complaint here. It's an unexpected token. So essentially, if you want to navigate the tuple like this, you have to put round brackets in here, and then it works just fine, and it gives you the right result. And of course, you can destructure a tuple of tuples in the sense that I can, for example, say let c comma d comma e comma f equals combined. So I take this tuple of two tuples of two elements and destructure it into c, d, e, and f. And at compilation time, the system actually checks that you're doing the right thing, because if I put like a G, for example, here, then, I'm not even going to be able to compile this, because the compiler actually checks the size of the tuples that you're working with. So, like I said, the tuple doesn't have to have elements of the same type, in the sense that, for example, you can have a tuple foo containing a Boolean variable, a floating point variable, and let's say an unassigned 8-bit integer, for example. So you can combine all of these, and then you can just, print line it in a similar fashion like we had before. So let's see what this gives us. This works just fine. You get true 42 minus 1. And another thing is, what if you want a tuple of a single element? Well, this becomes a little bit less intuitive, but essentially, if you want a tuple of a single element, you do use the round brackets, and you have your value in here. However, if I do it like this, let's just put a 42 and let's print line this. So the meaning of life, as always, let's output meaning here. So I'm going to run this. And this gives me a 42. And you'll notice there are no round brackets around this. So essentially, we didn't make a tuple. We made an integer, and those round brackets are redundant. So the question is, how do you make a single element tuple? And the answer is very simple. You simply put a comma in here. You put a comma, and then you have a tuple of just a single element. And it's also going to output it with a comma, which is a bit bizarre. But that's the way you make tuples of single elements.